The James Webb Space Telescope has once again pushed the boundaries of our understanding of the universe. This time, its gaze has turned toward one of the most tantalizing targets in our cosmic neighborhood, Proxima Centauri b, or Proxima b. Located just over 4.2 light-years from Earth, this exoplanet orbits the red dwarf star Proxima Centauri, the closest star system to our own. What makes Proxima b especially intriguing is its position within the habitable zone of its host star, a region where temperatures could, in theory, allow for the existence of liquid water. For years, scientists have speculated about the planet's potential to support life. But now, with the unprecedented capabilities of JWST, we may be getting our first real hints, not just of habitability, but of something far more profound. Unlike Earth, Proxima b is likely tidally locked. This means one side of the planet always faces its star, basking in eternal daylight, while the opposite side remains in endless darkness. For a long time, scientists believed such worlds would be too hostile, either scorched or frozen. But there's a narrow band between the two extremes, known as the terminator zone, a twilight belt where the temperature might be just right for water to exist in liquid form. And now, JWST's data seems to support this very idea. By capturing the infrared spectrum of the planet's atmosphere during its transit, JWST has given astronomers unprecedented insight. Advanced filtering techniques revealed temperature gradients and energy transfer patterns, suggesting active atmospheric circulation, with heat flowing from the star-facing side to the dark side. This redistribution is a critical factor for climate stability, and a hallmark of Earth-like weather systems. Even more astonishing were traces of methane in the atmosphere, methane in quantities that are difficult to explain through geology alone. While volcanic activity or hydrothermal vents can produce methane, they typically leave behind other chemical signatures like carbon monoxide. But in Proxima b's atmosphere, these were absent. That discrepancy raises a provocative question. Could this methane be biologically produced, much like it is on Earth by microbial life? Adding to the mystery was the detection of an unusual spectral absorption feature, one that strongly resembles chlorofluorocarbons, or CFCs. On Earth, CFCs are entirely artificial, used in refrigerants and industrial processes. They have no known natural origin. So the idea that such a compound, or something eerily similar, might exist in an exoplanet's atmosphere set off a wave of speculation. Could this be evidence of intelligent life? Technological activity? Or is there a geological or chemical process we have yet to understand? Researchers are approaching the discovery cautiously. The data is still preliminary. More observations are needed. But if verified, this could represent one of the most significant discoveries in the history of astronomy. JWST also recorded variations in Proxima b's reflectivity, or albedo, a measure of how much light a surface reflects. These changes across different regions could imply cloud cover, oceans, or even vegetation. While the telescope can't image the surface directly, the way light curves and shifts over time hints at dynamic weather systems and rotating surface features, possibly continents, storms, or large liquid bodies. Another surprising result was the measurement of the planet's atmospheric density, found to be thicker than previously believed. This is a crucial piece of the puzzle. A thin atmosphere, like Mars, can't retain heat or block harmful radiation. But a denser atmosphere allows for stable temperatures, liquid water, and protection from stellar flares, essential ingredients for habitability. In fact, JWST observed how Proxima b's atmosphere scatters light, in patterns similar to what we see on Earth, particularly the phenomenon that makes our skies appear blue. While Proxima Centauri is a red dwarf and emits mostly infrared light, the atmosphere on Proxima b appears to efficiently scatter this radiation, suggesting the presence of complex molecules or even aerosols suspended in the air. Most significantly, there's indirect evidence of a magnetosphere, a magnetic field strong enough to protect the atmosphere from being stripped away by radiation. Proxima Centauri is known for its intense stellar flares, which would typically erode an unprotected atmosphere over time. Yet Proxima b's atmosphere appears surprisingly intact. This suggests some form of magnetic shielding, similar to Earth's. Without it, life on the surface would be nearly impossible. Further long-term data from JWST also revealed an impressive stability in atmospheric conditions. Over several months of observation, the temperature and composition of Proxima B's atmosphere remained remarkably consistent, even as its star emitted variable radiation. This kind of climatic stability often points to complex feedback mechanisms, like Earth's interplay of oceans, clouds, and biological systems. In other words, the planet appears to be self-regulating. Perhaps the most unexpected discovery was a warmer than expected night-side temperature. In theory, the dark hemisphere of a tidally locked planet should be icy cold. But Proxima B's night side seems to retain heat, more than what atmospheric circulation alone would account for. This points to internal heat sources, possibly geothermal activity, or even plate tectonics. On Earth, such activity sustains entire ecosystems deep in the ocean, where life thrives without sunlight, feeding off chemical reactions near hydrothermal vents. If Proxima B hosts similar energy systems beneath its surface, it expands the range of possible biospheres, environments where life might thrive underground, away from harsh surface conditions. Such discoveries redefine what it means for a planet to be alive. But perhaps what's most thrilling is this. Proxima B may not be an exception. It may be the first of many. Red dwarfs like Proxima Centauri are the most common type of star in our galaxy, and they often host Earth-sized planets. These stars were once considered too volatile, too dangerous. But now, with new data, we're learning that their planets might be far more resilient than we thought. Thanks to JWST's unparalleled sensitivity, we can now distinguish between geological signatures, biological markers, and even potential technosignatures. And in the case of Proxima B, all three seem to be present, in a delicate, hard-to-ignore balance. The implications are staggering. Proxima B might not just be habitable. It might be inhabited. To take the next step, astronomers are coordinating with other major observatories. The Extremely Large Telescope, ELT, in Chile and NASA's upcoming Nancy Grace Roman Space Telescope will both play vital roles in confirming and expanding upon JWST's findings. These instruments will allow for higher resolution measurements, more transits, and deeper insight into the planet's atmospheric behavior. Meanwhile, targeted radio observations by SETI arrays have already begun, scanning Proxima Centauri for unusual electromagnetic signals that might accompany intelligent activity. While we've heard nothing definitive yet, this effort represents our most focused attempt yet to detect alien civilizations just beyond our solar system. If even a fraction of JWST's data proves accurate, Proxima B could become the most important world in the search for extraterrestrial life. A potential biological or technological oasis, just over 4 light-years away. What the James Webb Space Telescope has delivered is not just another planetary profile. It's a window into a world that might be alive. For decades, humanity has looked to the stars, wondering if we are alone. Now, thanks to the JWST, we may finally be approaching an answer. And that answer could be orbiting the star next door. Here at Discovery 2.0, we'll be following every new development from JWST and beyond, bringing you closer to the most profound discoveries of our time. Because the search for life, for meaning, and for our place in the cosmos, is far from over.